Hello everyone, welcome back. So we are going to continue the parallel stream now. So what I'm going to do now, I'm going to create a solve another use case. Okay, so we are going to work with our person repository, which we already have it. Okay, let me create a new class, parallel stream use case. So I'm going to have a main method here. Okay, so what is the use case? We have a person repository, right, which holds the list of personalities, right? So here I have a list of hobbies also. Okay, so what I'm trying to do is I'm trying to retrieve the hobbies. Okay, so I want to retrieve the hobbies of each and every person. I mean to say all the person hobbies. Okay, so what I'm going to do is I'm going to create a new method here, which was saying static, sorry, come on, static, and it's gonna return list of string, which is nothing but the hobbies. Get hobbies by sequential. So this method is going to be parallel flow. Okay, so we need to return the data. Okay, so first thing we need to retrieve the person repository. So under the person repository we have all the person list, right? Person repository dot get of all persons, and then I'm going to open up a stream, and then I'm going to use the map because I need to retrieve the hobbies inside the person class, right? So person and inside get hobbies. Okay, get hobbies is a list of string, right? So I cannot directly collect as a list, right? Okay, let's continue that. Dot collect, I'm going to collect as a collectors dot to list. Okay, but there's a problem here. Okay, it is not going to return as a list because person and it has a list of hobbies. We need to flatten the map. Okay, so under the list we have a stream. Okay, so now it will return list of string. Okay, so I'm going to copy paste the same method hobbies by parallel, but here I'm going to use the parallel stream. Okay, okay, we did everything, right? But another thing, okay, we need to find out which method is running faster, right? So what I'm going to do is I'm going to write a start time or start int start is equal to system dot system dot current milli. Okay, it's going to long, right? So I'm going to have another variable which will return the end. So here, okay, what I'm going to do is I'm going to modify method like this. Hobbies. Let's copy this entire thing. Control X, Control V, and it will return the list of hobbies. Okay, so I'm going to copy the same method again. So instead of stream, I'm going to use parallel stream. That's the only change. Okay, and I'm going to print the data. Parallel duration end minus start. So I'm going to do the same thing in the other method as well. Just okay. So here it's going to be sequential. Okay. Now we have things ready. Okay. What I'm going to do is let's call the methods. The first method is going to be get hobbies by sequential method, and then another one is by parallel. Okay, first I'm going to run the method and see how the time duration is difference between these two methods. Run as Java application. Now you should be able to see the difference here. See, sequential duration is 88, parallel is 7. It's very much faster parallel, but we just need to think about why this much time difference. Okay, the reason is here. So what we are trying to do, we are trying to flatten the map. That means there are some conversion is happening here, right? Okay. So while conversion is happening, it will take little bit more time because it's not only mapping the data, it is flattening the data and again mapping it. So that conversion part is happening. But when the parallel process is doing the same thing, what will happen is since we are using the parallel stream, there are multiple threads sharing the job and they're all together doing the same job and give the result. But then the sequential way, it's a single, see, it's only the single thread handling the entire operation. So it has to be done one by one. So one has to wait for the previous one. The next one has to wait for the previous one. So it happened to the till start to the end. So that is why we have this much huge time differentiation. From this, we might understand when to use parallel, when not to use parallel. Okay, so whenever the data flow is happening directly, we can go for parallel stream, and even it's okay to go with the stream also. But what we are trying to understand is when to use a parallel. Okay, so here we are flattening the data and then mapping it. Okay, there are other scenarios similar to this, but we should not use the parallel stream. So which we'll discuss in the next video. Thank you.